The 5-pound containers are individually wrapped into 1-pound packages. These are sealed in plastic. The flux found on aluminum welding rods will absorb water from the atmosphere. Some electrodes will not survive outside of the packaging for extended periods because of their hygroscopic tendencies. These 1/8 inch electrodes are 14 inches long and coated with a light flux. Today we'll be using a 2012 PowerArc 300 to demonstrate the welding capabilities of the aluminum electrodes. Look for our new version of the PowerArc 300 to be rolled out in early June of 2013. To weld aluminum, make sure the electrode holder is connected to the positive. And of course, make sure the work clamp is in the negative. On our units, the outside negative terminal should be used. For the demonstration, we'll be welding on scrap aluminum. You can see where the oxidation has been removed. The metal should be completely clean for best results. We'll be making a simple T-joint, allowing us to make a nice fillet weld. We'll begin by setting the unit up near the upper end of the electrode amp range per the manufacturer's instruction. We'll set a slight arc force and a hot start since this is the first weld we will make with it. We'll begin by tacking the 1/8 inch aluminum plates together. Here you can see the tack welds. What looks to be incomplete fusion is actually the flux peeling off from the edge of the metal. We'll remove this flux before we start welding. Here you can see that the flux is covered over the end of the electrode even after 2 small tack welds. This needs to be removed every time the arc is restruck. Remove just enough flux so that the aluminum part of the electrode touches bare metal. Since the aluminum electrode deposits metal very rapidly, use a tapping motion to start the arc if possible. Here you can see how fast forward travel is. It's much faster than steel or stainless. To evenly deposit the metal, rapid oscillation of the electrode may be necessary. The short weld that was just put down used over half the electrode in just a few seconds. You can see how the flux flakes off after the weld. The flux remains molten almost in a runny state for several seconds after the weld is completed. Remove all the flux if possible before restarting the weld. This will give the weld time to cool and prevent too much heat from building up in the aluminum. As the aluminum heats up, it will be necessary to reduce the welder amperage. We've changed camera angles so you can get a better look at the restart and middle part of the weld. During this segment, we left the amperage unchanged. You can see how much further the weld flows out as the aluminum heats up. You can now begin to see how the slag coating flows over the metal in an almost watery state as more heat is introduced into the weld. At this point, we made some changes. We reduced the amperage by 15 amps to 105 amps and increased the hot start for a smoother start. Then we increased the arc force up to 50%. At this point, the slag became difficult to remove and required a more intensive effort. At this point, you may have already noticed how short the arc length is. Any place where the arc length gets too long, the metal will not go into the weld but fly out in large molten balls. The weld has been completed and we're giving it a final cleaning with a stainless brush. You can see some weld dissimilarity. This is a result of experimenting with different machine settings, electrode angle, and arc length. As you become more experienced, consistency and appearance will improve. It takes a little practice to recognize when you need to step down the amperage. Although you don't see much penetration on the backside, the weld has been fully fused at the root. Remember that the electrodes are hygroscopic and will rapidly absorb moisture. It's a good idea to seal the remainder of the electrodes with a vacuum sealer to keep them from wasting.